Hi there. So as we have discussed in the previous video, the first step towards figuring out how to make our neural networks learn is to measure the error. Once we measure the error, it will represent the quality of our predictions. For various mathematical reasons, it's much easier to focus on measuring error and trying to make it as close to zero as possible, as opposed to using some other measurement of prediction quality and trying to maximize it. So here in this video I will show you how to measure the error in the simplest and most convenient possible way. There are many ways to measure errors, it turns out, and all of these ways have their own applications, but in this case we will learn the easiest way that we will use in the future. So the way to measure the error we will learn today is called mean squared error. I will take you through the code and then I will explain to you why it is called this way and why it should be squared. So let's just write the simplest code and see how it works in practice. So let's imagine that we have inputs. That would be like our input neuron, and it would input the 0.2. Then we would have one weight. It would be 0.4. I'm going to use plural instead of singular variable names, but here we will just have one input and one weight. The reason I prefer to use inputs instead of input is that input, as you can see, it's highlighted by my editor because it's some kind of a reserved word or a reserved function in Python, and it's best not to name your variables as input. So I will just use the plural name inputs. And the next thing we will have is target prediction. Target prediction. It will be, let's say, 0.7. These numbers are random, I'm just making up to give you an example. So where does it come from? Well, if you remember the flower example, there's like a table of many examples of data, and the inputs would be our measurements. Like in case of the flower species, that would be measurements of a flower, and the target prediction is the thing that we want to learn how to predict the outputs. We already have some training data that we will be able to use to train our neural network, and it will contain all of the measurements and inputs, and it will contain all of the correct predictions that we were supposed to make. So everything we are talking about is concerned with training data, not making predictions from scratch from unseen data, but from the data that we already have and know the correct answers for. So this is the target prediction, the thing that we want to predict, whether it's flower species or the value, the weather, or the value of a stock market, whatever it is that is your goal to predict. Next thing we will define is, as always, our simple neural network, but instead of creating an function, I will write it in one line. I will just write prediction equals inputs multiplied by weights. In the previous videos, we have wrapped this into an ANN function, but for this very simple example, this will suffice. I will just take these inputs, multiply them by these weights to see. And by the way, weight here is also completely random. I've just made it up. It is not going to correctly predict the target prediction that we want. So here we will multiply the inputs we have by some random weight, assuming that we haven't trained the neural network. And let's see what prediction is. It's going to be very tiny, 0.08. It doesn't matter. So the next goal is to create our error. It's going to be very simple. Error will equal prediction minus target prediction. And it's all going to be squared. And let's print out the error. Error. It's going to be our error. Excellent. So that's it. That's the formula that you need to memorize and understand for predicting, for calculating so-called mean squared error. So let's go through it and understand why it is the way it is. First of all, prediction minus target prediction is by how much your prediction has missed. I mean, if a prediction would be identical to target prediction, then this part of the equation would turn out to be 0, and 0 squared is 0, and the error would be 0, and that was exactly what we are striving for to accomplish eventually. But for now, we will just look at the distance. Now, what is squaring for? What does it accomplish? So there are two reasons why our error should be squared. First of all, it allows us to make sure that the error is always positive. Imagine it like this. Picture an archer that is trying to hit a target. And he might overshoot the target or maybe undershoot it. But either way, if he overshoots a couple of inches or undershoots a couple of inches, a couple of inches is a couple of inches, the error is the error. It doesn't matter whether it's positive or negative. It's going to be very important because in the future, as we are going to be learning from data, we will have a lot of examples, maybe thousands, maybe hundreds of thousands of examples. And imagine different examples will result in different predictions with different errors, and some of them would be positive and some of them would be negative. Then, if our errors wouldn't always be positive, then they would cancel out. Like imagine we have two examples, and in the first one we have an error of 100, and in the second one we would have an error of minus 100. If we would try to average those errors together, we would end up with the error of 0, and we would be super happy, like, oh, we have made perfect predictions. So even though errors are huge, if they can be positive and negative, they can cancel out. But in that case, why wouldn't we just take absolute value? It's definitely possible for some cases, but most of the time we will want to square it instead of just taking absolute value. And that is because squaring amplifies large errors and reduces small ones. So if you will multiply it, if you square a number that is between 0 and 1, it will become even smaller. While if you square bigger, it will become even bigger. And the bigger the error is, the more it will be amplified. It is a very convenient and important property, and this is exactly what we want in training our neural networks. It allows us to, quote-unquote, pay attention to big errors and ignore small ones. Because we will look at the errors that are bigger, that are amplified more. So by measuring the error this way, you can prioritize big errors over small ones. So this is very simple. This is called the mean squared error. If you would not want to square it, there is also something called root mean square error, where you square the error and then take a root of that. But this is beyond the subject of this video. There are many ways to measure error we will research. But for now, this is enough. Understand this formula and get ready for the future videos, because we will use it to figure out how to make our predictions better. Alright, I'll see you next time.